Hi, my name is Krzysztof Krasiński-Sroka. I'm a tech lead of Widgeters, a Flutter consultancy based in Poland, and a Google developer expert for Flutter. This presentation is called When Flutter Goes Red, and it covers the topic of bugs and errors you might encounter while developing a Flutter application, and how to address these bugs. This presentation cannot cover everything. Dealing with bugs takes easily a third of a software development time, and we have less than 30 minutes now to discuss it. So without any further ado, let's start. This talk is about 1. Where do the errors in our code come from, and 2. Most importantly, what can we do about them? So on the topics where do the errors come from? There are basically two things that cause errors. 1. It's equipment failure. Basically cosmic radiation, end of life of any of the hardware that we use. Could be somebody even tripping on the wire in a data center. But the ones that we are going to cover are caused by incorrect expectations about what the code does. These are not necessarily expectations with respect to your code. These can be expectations of people writing a dependency that your application uses, such as the SDK or a library. Code is actually never wrong per se. It does exactly what it was written to do. You cannot bargain with it to have it work without bugs. It cannot be reasoned with, and it will absolutely not stop doing what it was written to do. There are several types of failures common in Flutter. The most common thing is a precondition failure, when the application is in a state where it cannot really execute what it's tasked to. This includes things like invalid function parameters or variable values. From very simple examples like division by 0, where 0 is an invalid parameter, or index out of range in an array lookup, as well as more complicated and Flutter-specific things. For example, calling setState when a stateful widget is unmounted, or having multiple identical widgets with the same global key. UI failures are the other type of failures. It's basically when the UI doesn't render as we expect it to. This might be wrong size, wrong alignment, or positioning, or clipping, things that really don't look good, or at least don't look as we want them to. The third common failure is performance failure, when the application works correctly and looks correctly, but it does so much slower than expected or is taking too much resources. Flutter isn't really a problem of itself, but naturally might affect the rest of the system and slow down the whole application. There are more things, there are more failures like syntax errors, but I won't focus on them now. Let's focus on the first three types of problems. What to do when we encounter failures like these? Have you ever seen a Stack Overflow question where the OP asks for help with an error and includes at most one line of debug output from the application? It's really hard to help anybody if they don't provide the most useful information, the output logs. Output logs in Flutter are by far the most useful things to start with. Flutter, unlike some other tools such as a C++ compiler, produces very readable output when it encounters an error. Let's take a look at some common cases and try to analyze them by looking at the output logs.
Let's take a look at this application. This is an application I wrote some time ago, and its main orientation was supposed to be horizontal. However, I didn't really check what happens when we go into portrait mode. So let's see. Whoopsie. We can see that on a screen it appears that there's a mark saying Well, right overflow by 244 pixels. You need to trust me, this is very small. And that actually my name on the right hand side doesn't really fit into the widget space. So how can we go and see what's going on? Well, let's take a look at the Debug Console. I'm using VS Code as running this application from VS Code, so it appears in an integrated Debug Console here. But if you use other IDEs or you run the application from a console itself, you should see a very similar output. I'll hide the application window for now, and let's focus on what's here in a console. We see the following assertion was thrown during layout: RenderFlex overflowed by 244 pixels on the right. Well, that's nothing new, but we can see already some things. The Flutter message actually prints out which widget was the one responsible for this. Let's take a look. Okay, so this is a widget, the RenderFlex widget, that we actually seen overflowing. And yeah, it contains a text. It contains, well, two texts that are not really visible in the screen. What can we do about this? Let's see in the Debug Console. Well, we can inspect this widget in Flutter DevTools. We will do that later. The overflowing RenderFlex has the orientation of axis horizontal. Well, that is a row. It has a horizontal orientation. The edge of a RenderFlex has been marked in the rendering with the yellow and black stripe pattern. Well, yes, we can also see that. Thanks, Flutter. Consider applying a flex factor, using an expanded widget to force the children of a RenderFlex to fit within the available space instead of being sized to a natural size. So here we actually have even a suggestion. What can we use? Well, we should use the expanded widget somehow. And I won't go into details of how this works, but let me try applying expanded to the text widgets. Okay, no, this is actually going to be expanded column. Wrap with widget, expanded. Let's see what happens now. Well, the application looks okay, although I still have some problem here, I think. No. Okay. No, I don't. Reloaded one of the 574 libraries, and that's it. That's how the application looks now. And yeah, the suggestion that the Flutter SDK said was actually correct. Let's apply some expanded. I won't go into details, as I said, but if you don't know what Flex is and you want to learn, then you can take a look at the flutter.dev documentation on box constraints and how to apply them. Let's go to the next error. Take a look at another example. Now, I have a screen that I can add new icons to. Let's take a look. I added the first icon, it's an eject icon. These icons are random. Let's add another one. Well, this is a back icon or share icon. I'm not really sure. Let's add another one. Oh no, something failed. Well, this message, as you can see, isn't really useful to us. Let's take a look at what's happening in the console. When we open the output, we might be a little bit overwhelmed by the amount of messages that Flutter outputs here. This is unfortunate in some cases, but Flutter tries to be more verbose than it really needs to be, especially when it encounters a particular error for the first time. Well, we can take a look at these messages, but the real clue to what's going on is on the very top. You should always take a look at the first message that the Flutter SDK puts to the Debug Console. Well, what says here is that animation controller.animate2 called after animation controller dispose. However, this link goes to the animation controller, which is in Flutter SDK. Is it possible that the animation controller is so dumb? Well, let's take a look more into what the message says. Well, failed assertion there. The relevant error-causing widget was list view. But when you go into list view, it's really not that much of animation control being done here. However, we pass this animation controller further down, which isn't a good practice, but it's here just for demonstration purposes. We might go into what's going on later. So actually the third element here is another widget of ours. Let's take a look at this one. Yeah, this animate2 was called after widget animation controller was disposed. Although the real problem, of course, is multiple disposers. We need to be aware that the problems are not exactly caused by the lines that the Flutter SDK points us to. These are just the reasons why the Flutter doesn't want to proceed or produces an error. We might debug in some other place, and we need to be aware of what we do and really read what's going on. The hint here was animation controller.dispose, and here we might take a look and see, well, when animation controller gets disposed. We could not only read the debug console, but write information to it. Well, fortunately, Flutter SDK allows us to do that. In cases where the default debug messages produced by the SDK don't really provide too much detail, we can use utilities such as debugPrint to write some information on what's going on. Let's here write some useful information of what's going on here. Well, we run dispose, but which widget does dispose really? Well, I know that we actually have this nice property called key. See, an icon card gets past a key. And maybe we can use that key to identify what's going on. So, widget.key interpolating in this string. Let's now save and try to add a few new icons. Let's see also what's going on in the debug console. Well, nothing disposed so far. Disposed with the key 0/1. Oh no, and that's the error. Well, let's filter and see what messages do we have. You see that we disposed of the widget 0/1 and 1/2. How do these keys get constructed then? Let's go up and see. Okay, we run dispose for the widget 0/1, so that is, well, I would decipher this for you, but that's the first widget in a list out of 1, so that was a widget when it was only one icon on the screen, and the second dispose was a second widget when there were 2. It's a little bit odd. Actually, when you take a look at this key is oddly constructed as well. We keep the widgets on a screen, however we shouldn't really dispose until we really leave the screen. What's wrong here is that the list view actually keeps track of its children, and if the key doesn't match, then it disposes of that widget. And when it runs dispose multiple times, well, we have that error. Let's just fix the value key, removing that mutable part. Well, now every icon should have a value key that's just entry.key, which is its index. Let's see if we can repeat this error. Oh no. Well, let's restart. Restart complete. Yes. Let's add some new icons. Great. Great. Marvelous. Nothing crashed. Oh, wow. This is how it looks. However, we could see that we can use debugPrint for small diagnostic messages. Nothing gets disposed right now, as we can see. Well, we remove this filter. We'll see some messages. Well, there's only one. We started application 355. But there are many more things that we can print out of the console. Of course, we can use debugPrint, but there are more specialized debugPrint utilities. DebugPrint stack, for example, can be used, and let me remove iPhone simulator. DebugPrint stack can be used to print out a stack trace in a nice form, similarly to what we've seen in the output, the default output by Flutter SDK. This is really useful in catch clauses, where we can inspect the stack trace of an error and see where did actually the cause was. Other things include that's a lot of them. DebugPrint, for example, begin frame banner, end frame banner, which can be used to investigate what's going on between the frames in Flutter. And debugPrint layouts, debugPrint mark needs layout stacks, and lots of very detailed things we can use with debugPrint. Most of the time you won't use them. However, it's nice to know that Flutter actually gives you some tools for you to just crudely inspect what's going on. Let's now go to the next kind of problem. Now go back to the first problem that I've shown you in my app, the overflowing widget here. There is another way than just inspecting debug logs and figuring out what to do. For some time already, Flutter has what's called the Flutter Inspector page integrated into the DevTools, or called previously DevTools, which is a suite of tools helping you develop Flutter applications. Let's take a look if the widget inspector or Flutter inspector can help us with this. So when I click on this icon in VS Code, I get this kind of view, which is really nifty. On the left hand side, you can see the tree, the widget tree of my application, including the root, my app, material app, down to the images and text. The right hand side is yet not visible, but it will shortly change. So this is actually the view of my application. When I hover over some widgets, we can see some printed values of it, or inspected values of it, like what's child. But it's not important for now. We want to fix the original layout problem. And with Flutter DevTools, it's really easy. Let's go to the row which was the source of our problems. Well, you can see that actually the Flutter DevTools opened up the editor with this row being highlighted. This is really good, because if we want to actually see which row is that, we don't have them described here and have multiple similar widgets, we can get navigated exactly to the line that we should care about. However, the layout expert also shows us something interesting. You can see that this information wasn't really available or clearly available to you in a console, that the width of this row widget is 358 pixels, well, with the constraints from 0 to 358, but the children take 602. So let's try to find out how we can fix these children without touching code at all. We can actually inspect the children of a row as if it was a row, but in a kind of a scrollable view. And then we can expose a column that is a source of our problems. As you can see, it also has this striped bar, and it also has a message. It's maybe a little bit unclear if I show it a bit more. Well, that its width is 494, and it's more even than the total width of a row. However, we can manipulate some parameters here. For example, we can add flex, and adding flex 1 is similar to what we would do in case if we wanted to add expanded widget. This actually doesn't change the code, but lets you manipulate some parameters to see how the layout changes. You can also manipulate the position. This actually along the main axis. It's not going to change anything here, but if we do a cross axis, you can see a slight change in the positioning of the avatar. Let's go back to center. So that's one of the functions of the Flutter Inspector. There are a couple of more interesting features. For example, we can fine-tune the animations to run them by default 5 times slower to see what's going on when the animations go on. Sometimes the animations that we use in our production apps take only 100, 200 milliseconds. So this helps us to see better if something's going wrong there. We can also add overlay guidelines, which will show this kind of grid, including the paddings on a widget and the direction of some widgets. But this might be quite useful in discovering that, well, we actually have a position there because we have a padding and it might belong to some widget. One nice thing is also the select widget mode, which allows us to select any widget and be navigated directly from the UI to the widget in the widget inspector that's responsible for that part of the UI. Let's go and see another function. These are text baselines. Let me remove this first. Text baselines also fine when we actually want to inspect why the text doesn't align with each another. And there's one nice thing, which is a Repaint Boundary, which we can see now when we try to move pages forward and back. It's a boundary that changes the size, changes the color whenever a repaint in any widget happens. So actually we can only see it really clearly here around the whole material app, because it's a material app that repaints itself. You can see also on some other screens that repaint themselves, and they are tagged with different colors to see different phases of the animations. We can also highlight images that are using too much memory, but in our case, well, this is just me. I don't think I use too much memory though. Let's go to the next tool. What I'd like to show you is a debugger. Many of you might know Debugger since it's a concept that predates Flutter and Dart by many years and is available in many other languages. However, I think that many Flutter developers don't really use it, outright disabling it, or not using it to its full potential. And it's a very nice tool because it allows us to inspect a running application by stopping its execution and taking a look at what's really going on. So in VS Code we have this nice debugger view, and in other IDEs we have something similar. By default, the debugger will stop whenever we have an exception when it didn't catch, or there was no catch block associated with it. But we also can set our own breakpoints, and the execution of a program will stop when the program reaches the instruction on a line that a breakpoint is associated with. Let's go and see. Here we have associated a breakpoint on line 69 on the icon button that leads to the next page. So what happens when I press right? Well, the first thing we can see is a call stack. Basically, it's a sequence of calls that led to the execution of this onPressed. So you can see handle tabs, invoking some callbacks, and on the top is our very line. On the top we have variables. These include everything that's in a current scope, is accessible in a current scope as a variable, or this level variable, and unfortunately here we can only see this, that is my home page. We can also add some expressions to watch them during the executions independently of the local variables. These can be, for example, date time now, or something that is evaluated only in the current scope. So let's say controller.page. Now, on the right hand side in the toolbar, we can see several things. These buttons allow us to go navigate through the call stack or through the instructions that we are actually going through by either stepping into the deeper level of the call. So let's see what happens in the next page. It's actually jumped a little bit because it decided, well, it's not really important to go through this next page and page steps. They might have been optimized out. The locals have updated, and you can see that now that the controller page is not really accessible, we have error. However, datetime now works as expected. We can also press any on any position in a call stack to navigate to that place with naturally locals and watch expressions reevaluated when we do that. We can go up, down. Now, this button leads to a higher level, which actually also skips some stages and proceeds with just finishing on this onPressed. We could use also this button, which would step over the expression on the lower level, but continue on the next expression on the same level, and continue, which would lead us to continue the execution until the next breakpoint. As we can see here, one nice feature of breakpoints is also that we can edit them to evaluate some conditional expression when these breakpoints should be active. And let's say the expression is controller.page equals 0. So that this breakpoint is not going to stop us anymore when we press it many more times. However, when we go back to the first page, it's still going to work. That's it when it comes to debuggers. I think you should explore what they can do for you. And now, let's go to the final part.
I hope that you enjoyed my presentation. As I said in the beginning, this was just a brief intro into some of the most common causes of problems and solutions to them. For more information, I recommend reviewing documentation on flutter.dev or asking questions in the community forums, be it on Stack Overflow or elsewhere. Thank you and have a nice day.